Hello viewers, welcome to my channel. If you haven't yet subscribed to my channel, do subscribe it and do not forget to press the bell icon near the subscribe button so that you get the notifications of my latest videos. And do not forget to like and share also. In today's video, we'll be learning about the fundamental theorem of arithmetic. This belongs to the chapter 1 of mathematics, a very important theorem, but many students find a bit of difficulty in understanding this, so I decided to make a video on this fundamental theorem of arithmetic. The problem is that many of the students have forgotten what are prime numbers and what are composite numbers. So let me tell you what are prime numbers and composite numbers first, and then I'll move ahead in teaching you the statement of fundamental theorem of arithmetic. Then I'll tell you about its applications. Then I'll explain a few examples about it. Alright, so let me tell you what are prime numbers and composite numbers first. See, prime numbers. Prime numbers are those numbers which have no other factors other than 1 and the number itself. Prime numbers are those numbers which do not have any other factor other than 1 and the number itself. In the sense, the prime numbers, its factors are only 1 and the number itself. The factors of prime numbers are only 1 and the number itself. Okay, let me tell you a few examples over here. 2 is a prime number. A very important thing to note, 2 is the only even prime number. There's no other even prime number other than 2. 2 is the only even prime number. Okay, and the factors of 2 are only 2 and 1. It has no other factors other than 2 and 1, other than the number itself and 1. Here you have 3, another example. The factors of 3 are 1 and 3. Only 1 and the number itself. Similarly for 5, the factors of 5 are 1 and 5. 7, factors of 7 are 1 and 7. Factors of 11 are 1 and 11. So you see, in these examples itself you can understand, with the help of examples itself you can understand what are prime numbers. Prime numbers are those numbers which have no other factors except 1. See, everywhere you have 1, 1, 1 and the number itself. Here now the number is 2. The number itself is its factor. Here you have 1 as one of the factors and 3 is the number itself. The number itself is its factor. In all the examples you can observe this thing. Now going to composite numbers. Composite numbers are those numbers which have factors, not which do not have factors, which have factors other than 1 and the number itself. Which means the factors of composite numbers are 1, the number itself and some other number, etc. whatever. Okay. The factors of composite numbers are 1, the number itself and various other numbers. So the definition of composite numbers is the numbers which have factors other than 1 and the number itself. Which means it has many other factors unlike prime numbers. Now let me tell you a few examples. The first example is 8. I have taken this example. You can take any other composite number as an example. The factors of 8 are 2, 4, 1 and the number itself. That means 8. 1 and the number itself are also the factors. Other than that, 2 and 4 are also the factors. Now how would you factorize it as a prime factorization? 2 into 2 into 2. This is factorization. Okay, factorization. This is factorization, prime factorization, which means we express it as a product of primes. We are expressing 8 as a product of primes. Another important thing to note, 1 is neither prime nor composite. It doesn't come in any of these two categories. It is neither prime nor composite. Okay. Another example over here, I have taken 6. The factors of 6 are 1, the number itself, which means 6, 2 and 3. If you're going to factorize it, it will be 2 into 3 or 3 into 2, whatever. Okay. Now let me tell you about the fundamental theorem of arithmetic. If you understand what are prime numbers and what are composite numbers, fundamental theorem of arithmetic will be very, very easy to understand. This is why I explained about prime numbers and composite numbers in the beginning itself, so that you do not find any difficulty in understanding what is fundamental theorem of arithmetic. So the statement of fundamental theorem of arithmetic is every composite number. I've just explained about what are composite numbers. Every composite number can be expressed or factorized. Okay, it can be expressed or factorized as a product of primes. Even there I showed you how we express 8 as a product of primes. We wrote 2 into 2 into 2. As a product of primes, we factorized it. Prime factorization we did. That is what is given over here. Product of primes. And this factorization is unique. It is a unique factorization apart from the order in which the primes occur. Only the order can change. Only the order can change. Apart from that, it is a unique factorization. Every composite number can be expressed or factorized as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. Okay, this part over here, this factorization is unique apart from the order in which the primes can occur, can be expressed in another way. The prime factorization of a natural number is unique. Okay, the prime factorization of a natural number is unique except for the order of its factors. The same thing I have explained over here. Same thing in a different way. About the order, not the fundamental theorem of arithmetic, only about the order. The order changes, I told you, right? That is what is given over here. Now let me tell you a few examples about what I meant by order changes, unique factorization, or every composite number can be expressed as a product of primes. The answers which you want, you'll get here in the examples. I've taken 10 as one of the examples. 10 is a composite number, as you know, and the factors of 10 are 1, the number itself, that means 10, 2 and 5. These are the factors. Now, if you want to do the prime factorization of 10, you will write it as 2 into 5. 2 into 5, okay? 2 and 5 are primes. And we have done the prime factorization. We have factorized 10 as a product of primes. Now, I told you that the order changes, right? Now, you see here. 10, the same number we have taken. It is a composite number. Here it was given 2 into 5. The same thing I have written 5 into 2. Is there any change? 2 into 5 is 10 and 5 into 2 is 10. Is there any change? No. You see, only the order changed. The concept is the same. Only the order changes. The order of the prime changes. Now I'll tell you another example, 22. 22 is a composite number. Composite number. 11 and 2 are both primes. Okay, 11 and 2 are both prime numbers. I have written 22 as 11 into 2. Again, I can express 22 as 2 into 11. Nothing changes, right? Both are primes. Even here, both are primes. Here it's 11 into 2, but here it's 2 into 11. But both are 22. The prime factorization of 22. Another example I've taken, 20. 20 is a composite number. When you factorize 20, you get 2 into 5 into 2. The same thing you can write 5 into 2 into 2. The same thing again, you can change the order and write 2 into 2 into 5. Or you can write 2 square into 5. Or you can write 5 into 2 square. Nothing changes. The number is the same. So this was all about fundamental theorem of arithmetic. This is very simple concept All you need to understand is prime numbers, prime, P-R-I-M-E, prime numbers and composite numbers. All you need to know is detail about the prime numbers and composite numbers, and you should understand this part. The order of the primes can change, otherwise it is a unique factorization. Okay, now in this fundamental theorem of arithmetic has various applications in the field of mathematics, but in class 10 we'll be using for two main purposes, and they are, and now I'll tell you about the applications of fundamental theorem of arithmetic in class 10. In class 10 we'll be learning, we'll be using fundamental theorem of arithmetic to prove the irrationality of this kind of numbers like root 2, root 3 and root 5, etc. We'll be using to prove the irrationality of specific numbers. And second thing which will be second thing in which we'll be applying this fundamental theorem of arithmetic is exploring when exactly the decimal expansion of any number, any rational number like p by q or n by m, where the denominator, here q is the denominator, q is not equal to 0, and that decimal expansion is terminating or when it is non-terminating. Okay, we'll be learning it. Now what is a rational number? A rational number is in the form of p by q, say p by q, okay, where q is not equal to 0. Okay, q should not be equal to 0 because any number divided by 0 is not defined. So if it is 0 over here in the denominator, if you see 0, then it is not a rational number. Okay, see, second one is to explore when exactly the decimal expansion of a rational number, say p by q, or if you like a by b, take a by b, but there you should write, mention, of course you should mention b is not equal to 0. If you like x by y, to write x by y, anyway they are variables, so the denominator should not be 0. The decimal expansion of a rational number when it is terminating, when it is non-terminating, that's what we'll be using in fundamental theorem of arithmetic. Okay, so in the upcoming videos we'll be learning in detail about these two, about the applications of fundamental theorem of arithmetic. If you have any kind of doubts or any suggestions, do let me know in the comments section, or if you have any kind of requests, if you want me to make a video on a specific topic or on a specific chapter, even that do let me know in the comment section.